One of them wanted to be the security guy. He claimed he was a security guy.
Welcome to Security Guy Radio. What's your name, sir?
Steve Solgrove, President and CEO of Giant Gray.
What does Giant Gray do?
Giant Gray, we build true artificial intelligence for enhanced security and safety.
That's a big word, artificial
Big
intelligence.
word.
Back it up for me.
Well, we're doing it with, I'll give you another one, artificial neurolinguistics.
Oh, boy.
Is the technology behind the scenes that looks at a scene, looks at data, and builds a new language around that, hence being neurolinguistics.
So this is kind of like the big computer you see on CSI. It's here.
That is here.
It
yes.
is. And we were waiting for it, and now it showed up. So I read your background. I'm fascinated by this because this idea's been around a long time, and people have done components of it manually. In other words,
Correct.
You take a VCR camera and you program when to record, when not to record. You have to tell it what to do.
That's right.
But your system learns the machine, learns what the machines on your network do. It learns what the cameras are doing. It learns what your door access control records are doing, right?
That's correct. So what it does from a video perspective is it takes a look at the field of view, and over time it learns just like the human brain would. We develop a short-term, mid-term, and long-term memory of a given scene or a field of view, and after about 2 weeks, that field of view becomes to our gradient engine becomes extremely intelligent, and we understand what should be going on in that scene and develop the ability to alert when anomalies occur in that given scene.
So what would an anomaly be? Let's say, I hope this is true, let's say somebody at a company A listens to Security Guy Radio every night at 7 o'clock.
Right.
And does that for 54 weeks.
Right.
But on the 55th week, he does not log in at 7 o'clock and does not go to my website.
Correct.
Would the system pick that up to that small level?
On our cyber product, so Gradient C, it
Right.
would pick that up because we monitor network traffic at the MAC address level, and if that MAC address every Monday evening at 7 o'clock is signing in for your show, and that next Monday he doesn't do that, then it's going to say, hey, something's not right, and it's going to alert that that's an anomaly.
I'm fascinated that at that smallest level, it picks up on that.
And that's quite frankly from a technology perspective, you look at what we do in video and it being truly the most complex data source that you have in video, and being able to break that down to the pixel level and turn it into ones and zeros and analyze it is pretty amazing in and of itself. But with data, i.e. MAC addresses, it's very simple to do because we're already seeing ones and zeros, right? It's already data.
Oh, that's right. It's already converted, right?
It's already converted into a very easily understood language, if you will, for the gradient engine.
So we're going to see a demo in a minute, but I'm trying to get my head around this video thing. So your system's not recording the video.
It's not recording
It's already
the video.
recorded at the company level, wherever that is, stored wherever it is.
We only record the anomalies in typically a 10-second clip, and we place the anomaly right in the middle of that clip. So say 4, 5, and 6 seconds would be where the clip would sit in the alert that's posted up to the person monitoring it.
So my mind's racing as we talk because this is fascinating to me. So I'm going to throw up some scenarios here.
All right.
Banks, very regulated. Bank personnel, very regulated.
Correct.
Bank president doesn't show up for work, FBI gets called, right?
Yep.
That's what happens. It's pretty strict. So let's say the bank president pulls into his parking space. He's on camera. He pulls into the parking space every morning at 9 o'clock.
Right.
And now he's not there at 9. He's not there at 9:10. He's not there at 9:30. Is that an anomaly to the video part of your system?
It is an anomaly to the video part of the system, but even from a multi-sensor perspective, if he has card access going into that bank, we would also be able to monitor the access control perspective of that.
That he did not come into the bank.
Correct.
Yeah.
So perhaps maybe he parked in a different spot, as an example, and that in and of itself wouldn't be necessarily an anomaly per se. But if he didn't card key in at that time, that would then be an anomaly. So when you put the two together, it makes sense, whereas independently they may not mean anything to anybody.
What other businesses might this be applied to? Really, anybody that has data and video, right?
Anybody that has data and video, anybody that is really struggling with all the amounts of data and video they're dealing with. Most of the customers we talk to tell us that their biggest problem and their biggest fear is the unknown. And what we like to believe is that our system makes the unknown known. Hence the name of our company, Giant Gray. We really deal in the gray. Everything's not black and white. There's a lot of gray area out there. And that's the area that we play in most prominently is the gray. So we bring to light those things that you can't see or touch or feel at any given time.
Yeah, I liked when I saw your tagline. We see it. I immediately knew what you meant, because seeing it is not the same thing as it being there.
Correct.
Lots of data on the network, lots of noise, lots of things.
That's right.
I have all the data. That's great. What is it?
Yeah.
I'm not.
That's
how
right, Chuck.
do I sift through all these things? So, is there any concern about the artificial intelligence part, right? And I'm half kidding, because...
What do you mean? Is there any concern?
Well, I've talked to people in the industry. I talk to a lot of people, right?
Right.
And some people, smart people, say, I've done the math, and in 2025, our networks are going to go become self-aware, and that becomes artificial intelligence. In other words, it's going to come out and say, oh, I don't have a command or anything to do, so I'm going to stop. Well, guess what? I'm going to go find one now. And that's an idea of artificial intelligence.
And I wouldn't challenge that. I wouldn't disagree with that necessarily. That's probably true. And especially in the networking field, it's very advanced and very complex. And I wouldn't say that from a Gradient Cyber product that we have standalone, it's a decent product, but can it compete in the security world as a standalone solution? Probably not.
Right.
But in a multi-sensor fashion, it's very applicable, because nobody can do all those things in one package.
Tell me all the inputs you're going to get. We touched on video. We touched on data. I mean, there's so many things. Email, phone records. What are
virtually
things?
anything that's monitored, whether it be HVAC, whether it be any kind of control systems that are out there, financial data, anybody who's crunching numbers and doing analytics on data, the Gradient engine can be applied across all forces of
so
that
let's say I
business.
put this into my financial company.
Right.
Do I have to help it write some rules? In other words, I'm looking for Sarbanes-Oxley violations, and one of those violations might be, and I'm just guessing, that the CEO has to sign checks every Tuesday, and he only signs 30 checks, but today he signed 31 checks.
Sure.
And that's an anomaly. Do I have to help it learn that, or
you've got to, the engine's got to understand where it's pulling the data from.
Okay.
So there's some API integration. We have to map the appropriate fields to make it intelligent, to give you some value of what you're looking for.
And you guys
right?
are doing all that when you set it up.
Correct.
It's working with me.
Correct.
Okay.
Correct.
Can it be trained to, not train, train's not the good word. It's learning. It's not training, it's learning.
It's learning. It's all, we don't, one of the other strong points about our product is that we don't apply any rules.
That's interesting.
There are no rules applied whatsoever, whereas in every solution that's out there from a video perspective, even a data perspective, if you look at the SCADA world in the oil and gas, they set the SCADA sensors at a high and a low, and they're really set it at, call it 95% and 5%, so they can only see the high and the low. All that noise in between, the activity that potentially are taps on the shoulder, or small events that are going to lead up to a catastrophic event, aren't going to be caught in a rules-based system, and so we actually bolt on to the back end of that, and as an active listener on the line, make sense of the noise, and then we can actually provide precursor alerts to a potentially catastrophe event.
So there was a power plant hacked in Ukraine around Christmas last year. And they used a, excuse me, kind of a old-fashioned phishing scam. Opened up and started this denial of service attack, but that was fake. Because what they were doing was going around the back door and attacking and shutting off all the power, right?
Right.
So with Gray Giant, what I'm hearing is traditional network attack monitoring software catches things, but it's so voluminous. I mean, how do you know if that knocking on the door for your network is China
Right.
or your
That's
employer?
correct.
And so that's a rule-based system. Most of those network monitoring systems?
Not most, all.
They all are, okay.
They're all rules-based
Very
systems.
interesting. And so plugging your
It's
system,
just
which
like
is a
IBM Watson.
right?
It's a large database that I'm querying against, right, to get the answers.
Yeah.
Whereas I have no information. I know nothing other than what I've learned based on its installation time it's been installed. Whereas like on SCADA, it'll take 37,000 reads before I can intelligently give you an anomaly alert. Video, it takes 2 weeks. I think Cody mentioned that, or we'll mention that
That's
as well.
I expect it to be 2 months or something. That's fascinating.
Could be. Certainly,
But it keeps after 2
certainly
weeks.
the longer it's in, it's going to get better and
There you
better
go.
and better because just like, think of it like a newborn baby. When I'm born, eyes pop open, my sensories begin. I'm looking around. I recognize that if I cry, I get fed, or if I do something, an action happens.
Right.
My output is somebody else's input to me. Well, our system does the exact same thing.
Any resistance from network engineers to put this on their network because they own the denial of service attack monitoring. That's their
Sure.
job, and we don't need you. Any hesitation with those kind of things?
We sit behind all that, so we're non-intrusive to the network, and as well as any SCADA system or any monitoring system that's in place today. We sit behind that as an active listener. So we're actually giving more return for an existing investment that they have that they're really throwing bodies at to fix these problems or look at the analytics.
Any
around
success stories you could share, small or big?
it. There's one specifically is in Atlanta, big Metro Transit Authority there. They have increased their ridership as a result of the installation of this, and we have caught incidents online.
Oh, because you're catching maybe crimes, you're catching maybe
Crime.
times on the network, and so people feel more safe, so they want to ride.
That's
Well,
correct.
that makes sense. I never thought about it that way.
Oil and gas industry from a forensic perspective, pretty much every time we've done forensics in the oil and gas industry, we're batting 1,000 by taking historical data where there's a known event that has occurred, running it through the grading engine, and we're able to push back out to the end user those taps on the shoulders I mentioned earlier,
Oh.
and then that catastrophic event occurring.
Right.
And
That's proof.
and that's the intent, right?
Yeah.
That's
So you could
what
come
it's-
into if you wanted to sell me, you come into my company and say, you go pick something that happened, and I'm going to find it and show it to you.
That's correct.
Fascinating.
Or they can, cloud-based model where they can upload data just and use it as a forensic tool for themselves to speed up their analytics.
So this concept has been around a long time. I wrote a white paper at Disney about using point of sale data to figure out that if 3 guys come in at 10 o'clock at night, an hour before the park closes, and pay cash for a ticket, that's an anomaly.
Right.
These guys don't like to go to Disneyland. Even with their kids, they don't like to go to Disneyland.
That's right.
So something's weird, right?
Yeah.
But it's never been at this level, and I know this is a game changer, right?
Right.
Because people have been doing those small things I've discussed manually, and now we have artificial intelligence to learn it. It's a game changer. I'm fascinated by it.
Yeah, and we don't.
This is brand new stuff too, right? A couple years.
It's a couple of years. I mean, the technology itself has been we've been building it for about 10 years of technologies we've been building on.
Right.
And now we're productizing it and bringing it to market. But we're not really, I wouldn't say we're out replacing bodies that are out there in
Right.
the field, but we're making them more intelligent. We're giving them better information, real time, that they wouldn't normally get on their own, because half the time they can't look at or they can't touch all the sensors that are out there, all the video cameras that are out there. They just can't do it. They're overwhelmed.
It's too
with
much
what they
time.
have.
Can't be done. Yeah. Steve, it's been fascinating. Thanks for coming on Security Guy
Thank
Radio.
you so much. I appreciate it.
Thanks. Welcome to Security Guy Radio. What's your name, sir?
Thanks, Chuck. My name's Cody Falcon, and I'm the Vice President of Product and Operations here at Giant Gray.
And you're going to show us a demonstration. We just talked to Steve a minute ago, and you're going to show us a demonstration on how this really works.
Yeah, absolutely. So we'll walk through this, and when we dive into this demo, you'll notice kind of a wheel on the screen here, and that shows the various industries that Giant Gray's product Gradient plays in. So we'll look at probably the most relatable one here at this show is public safety.
Yeah, that's a
Well,
big topic now. Right.
Absolutely. And we happen to be working with 6 of the largest cities in the U.S. protecting the public within rail and public transportation. So we'll click here. So this case study is a case study on a large metropolitan city in the southeast. They have a metropolitan transit authority with several thousand riders per day. And of course, their goal is public safety and ultimately increased ridership on the transit authority.
Right, because if it's not safe, nobody's going to ride.
Absolutely.
That's the bottom line, right?
Absolutely. So the problem here is this transit authority has approaching 2,000 cameras. Right? When you do the math on 2,000 cameras, you're looking at 48,000 hours of video footage every day that these
A
guys
day,
are tasked
48,000 a day.
per day.
Wow.
And they're tasked with watching this in real time and trying to proactively monitor it and keep the public safe. It's an unscalable problem. So we went in, we put Gradient here, and the Gradient platform starts monitoring those cameras just like an operator would, builds an understanding of what's normal and expected to happen on these railways, and when it sees something out of the norm, it sends that insight down to that control room for response.
So it's monitoring. It's not part of the recording system.
right.
It's just learning what the existing recording system's doing.
Absolutely right. It's monitoring in real time. So we're looking at the live stream, and you hit the nail on the head. We're not recording.
Right.
So the hardware requirements on the storage side are very, very light because we're doing all of this in memory. So we deployed the Gradient product on all of their cameras. And after a few weeks of learning, we have a pretty good understanding of what's normal and expected to happen.
Just
And
takes a couple weeks for that many cameras?
Yeah, 2 weeks.
That's
2 weeks.
remarkable.
Yeah.
Then it keeps learning after that, I assume.
It's continuously
Yeah,
learning
right.
as well as forgetting, right? And that's the question we get often.
Oh.
Well, can it overlearn? What if it's been looking at Chuck's camera for 5 years? Well, it's continuously either reinforcing the model or forgetting the old model. So it's
Interesting.
an adaptive technology that never needs to be reset, and there's never a baseline to redo. And this really points to the scalability of the product. I mean, I think you nailed it with 2,000 cameras. We deployed these cameras in a day and a half with a single engineer because you no longer have to go to the camera and program a rule set. You just point an AI system to the IP address of the camera and let the system teach itself.
Right, because back in the day, I had about 250 cameras at Fox Studios, and I had to take each camera and say, okay, for the digital recorder, and we had some of the first, I mean, that was a long time ago, if somebody walks in the frame between 3 a.m. and 6 a.m.,
Right.
then call me.
Right,
But that was
absolutely.
a lot of work.
And imagine doing that across
Oh,
2,000 cameras
impossible.
across a 50-mile radius.
Right.
It's a lot of work.
Oh, and these cameras in this picture, that's right, it's a metro, so these cameras are
This
separated.
is all over the city, right?
Right, not one station.
Absolutely.
Wow.
They're all over the city. And so this Gradient product is now driving the police force and the Metropolitan Transit Authority's protection services. They're no longer sitting behind screens and hoping to catch something as it occurs. These insights are driving their investigation and driving where they put resources out on the
Right.
street.
That's amazing.
Yep.
Now, is there a way we can see something? There's like a mock demo of a...
So what we can do, if we go back, we can look, and of course the customer data is a little sensitive, so we have some example tracking here. Well, first we take a look at how the video architecture and how this plugs in
Right.
this particular deployment. So you have your cameras, right? And of course, some of these are still being migrated over to IP. A lot of them are still analog.
Yeah, a lot of
So-
them are analog.
Yeah, so we take that through from the source, through an encoder if it's analog, directly to the Gradient product. If it's an IP camera, we can take it direct.
Okay, so you're taking an analog camera and you're converting it for your purposes to analyze it with the
No,
converter.
we are receiving it from an encoder. So if
Oh.
it is an analog encoder, an analog camera, you have an encoder in line that's converting it to
Right.
a digital stream, and then we look at
And
that.
if the client doesn't have those, you're going to have to recommend putting those in.
If the client doesn't have that, oftentimes you'll see here this VMS, it's labeled DVR, NVR. We can pull those streams live through an integration from those sources.
Oh, that's amazing.
So we come across that quite a bit. You know, folks
Sure.
have antiquated architecture. They may not be able to provide you a secondary stream from the camera.
Well, in 2014, analog cameras still outsold digital,
Absolutely.
which is
Absolutely.
amazing, right?
Yeah. So we take that in, and again, we can take it from the camera, we can take it from an encoder, we can take it through an integration from a VMS. We do the analysis in real time, and we can push those insights into our interfaces, or as labeled here, we can push them back into the operator's workflow.
And push it out to a mobile device as well,
Absolutely.
which is extremely critical for
So
guard
the last
forces.
thing that we want to do, right, is put up another piece of software and another screen for an operator that's already overwhelmed.
Right.
We want to drive these insights into his existing workflow.
Do you think this replaces somebody monitoring a video camera system? A guard watching, I mean, at Disneyland we had thousands of cameras and we had to pay guards
Sure.
to sit there, right? It doesn't really replace them, but it
doesn't
helps them,
replace
right?
it, allows them to scale.
Right.
So now that guard can't, he's not tasked with monitoring 1,000 cameras. He's being driven on what cameras to look at
Right.
based on gradient.
Which they can't do anyway.
Right.
It's
So
a
the
fallacy.
AI is looking at thousands of cameras, and he's tapping that operator on the shoulder and said, "Hey, you may want to look over at this camera. This is driving your focus."
That's amazing.
One more thing. So this is just representative tracking. of what the Gradient product is doing. And there's a lot of science here that we could spend the next 2 hours talking through, Chuck. But what's interesting here, really to point out, this is Gradient working under the hood. So every object that's moving, the Gradient platform behind the scenes is putting a tracker box on that object. And if you notice, the tracker boxes are not square, which is pretty common. They're
Right.
ellipsoidal. So we can sense direction and velocity, and we track them as they turn.
Interesting.
So that's just one of the feature classifications that we bring in. And we're constantly learning. So Gradient watching this scene for, say, 2 weeks, it would have a pretty good understanding that this is an intersection and directional traffic flow. That is what normally happens.
Now, see that red car keeps doing the loop?
Yep.
Can it learn that red car, that particular red car, keeps coming back on a Tuesday?
It would not learn the red car, but it would learn that looped pattern. It would say objects of this shape, size, color
Okay.
normally do this. But it's
And-
not
and-
going to say this red Prius is
Well, but
doing
then
this.
you might go back there and say, look, there's that red Prius I've been looking
Absolutely.
for, because you're
Yeah.
seeing every time at exactly the same time, or whatever
right.
the anomaly is.
That's right.
Very interesting.
And the reason we say 2 weeks is because, we need, or the system needs a few Tuesdays to know what a Tuesday at 2 a.m.
Exactly
is
right.
supposed to look
Well,
like.
I'm amazed it's 2 weeks. I thought it would take 2 months or something.
Like this intersection is probably pretty low key on a Sunday.
Okay, so I'm an old traffic motor cop, right?
Sure.
So I'm looking at that and I'm thinking, I could determine vehicle patterns. I could say, look, every Thursday we have 1,000 extra cars. What's going on there?
Absolutely.
It would tell me
so
that.
absolutely. So we have a system deployed at a state capitol building, and they're doing just that. They're using the visualizations of what the Gradient system has learned to drive their responses in their day-to-day operations.
Yeah, staffing,
so
right?
Yeah. Every morning they come in and they have a daily threat briefing, and they assign officers or resources to different areas. Well, they can look at Gradient's clustering and see where things happened yesterday and the week before and the week before. And if all the traffic is normally here, and then last night we saw traffic back here, that's where we need to have an officer for
You know
tomorrow.
what? You could detect a swarm in them all.
Absolutely.
Because now there's 5,000 extra people showing up all
That's
at once.
right.
Interesting. Fascinating. Well, gee, thanks for giving us a demo here.
Yeah,
Thanks for coming on
absolutely.
Security Guy
Thanks for
Radio.
stopping by,
Appreciate it.
Chuck.